is Shingi, the CEO of Asoba, and today I want to talk about Internet of Things within energy management. So to start with, what is Internet of Things? So Internet of Things refers to a myriad of different devices that are not necessarily personal computers or phones, but maybe things like refrigerators, like inverters, like toasters, like cars, that are also communicating and sending data back and forth to the internet, and therefore accessible to users at other locations for various purposes. These devices may or may not also involve a level of remote control, again via the internet, and again based on data that they may or may not be sending. So within the context of energy, what does Internet of Things refer to? It primarily refers to things like smart meters, things like smart inverters and controllers. So these are all components of an electricity grid that do various things. So for example, a smart meter is going to do things like counting the electrons that are either produced or that are demanded by a particular off-taker or a metered location, such as a building typically. You might have inverters, so these are components within a solar array or of any type of generation, right? And they do things like change the current of the type of electricity. So you might be generating at DC or direct current, and you might need to switch to invert it to AC, for example. So that might be a use case for the inverter. You also have controllers within a grid, and controllers are the components that essentially make decisions or execute decisions that are made manually by a human or by a machine. And so they'll do things like to say, based on the decision that I got from this other source, I am going to only generate 300 kilowatt hours from this diesel generator, and I'm only going to route 700 kilowatt hours from this solar inverter, right? So those are the types of things and the types of use cases that you'll see for Internet of Things within an energy management system. So they're particularly important to both decentralized grids, but more specifically to renewable energy generation. Not just the generation component, but then also the transmission and the distribution of renewable energy generation. And the reason why that's important is because the traditional grid system is very centralized. So you might have one or a small set of very large singular generation points, and then you have this sort of spider web network of transmission and distribution lines. So you have your transmission lines, you have your distribution substations, etc. But they're essentially webbed out in sort of like a spider fashion. Now, renewable energy, though, because it's of its portability and the ability to build small scale generation at scale, means that you have, instead of these singular generation points, you have a wide range of generation points. So going from one single power plant, a single coal power plant, you might instead have 10,000 rooftop solar arrays distributed across that same service area. And the management of that singular power plant is very different from the management of 10,000 ostensibly independently operated distributed energy resources that all have their different meters that are all submitting data and so on. And so the grid management system of the future will take data from the smart meters, from the inverters, make decisions, and then send data to controllers to then actually execute those decisions or settle those decisions at the layer of the actual energy generation. So that's an example of how Internet of Things is a very important part of energy management systems, particularly energy management systems of the future, as we shift away from these centralized grid systems and more towards decentralized systems in the future.